installment of Fractions with Mr. Paul. So much fun, isn't it? Today's video is about simplifying. Now, simplifying has many different forms. If we look at the term simplify, ideally at the end of every question, we're going to have A over B, where A is the smaller number and B is the larger number. This is something called a proper fraction. Okay? This is called a proper fraction. Proper. This is ideally how we want to leave all of our answers. Now, there's another form where we have A, B over C. In this form, B is still smaller than C is still larger than B, and A is just a whole number. Okay, so this is called a mixed fraction. Another important one. Now, the third one is kind of weird because it's A over B, where A is larger, B is smaller, like so. Ooh, look what I just found. I found an extra pen. This is called an improper fraction. The reason it's called improper is that our brains don't really like this. If I tell you that I have 15/3 pizza, I have 15/3 of pizza, what I'm really saying is that I have 5 pizzas. Now, which is easier to understand? 15/3? Remember that this line in the fraction means divided by, so that'd be 15 divided by 3, or 5. Our brains are naturally predisposed to go for the whole number. Now, the reason we actually have improper fractions is for 2 operations: multiply and divide. Okay? When you are multiplying and dividing, we cannot have mixed fractions. So we actually have to learn how to go in between these two types of fractions back and forth. So that's what we're going to be looking at. All right. So I have 3 circles here. What I'm going to do is I'm going to shade in the entire first one, the entire second one, and 1. Okay, so this is going to be pretty simplistic, and the key is to this is don't make it overly complicated. I'm going to show you a couple of different formulas to solve these, but really as long as you can visualize this, you'll be okay. So the very first thing is how many holes, let's call these pizzas because I'm hungry and I like pizza. How many whole pizzas do I have? I have 1, 2, and is this one whole? No. So I have 2 whole pizzas. That's this big number. That's a whole. So in this one, I have 2 wholes. And what fraction of the 4th pizza do I have? I have 1 out of 4. I have 1/4. So 1/4. So what I get here is 2 1/4. So far, so good? Okay, now this is where you need to pay really close attention. That's supposed to be a heart. I don't even know why. The denominator of the fraction is the key to this whole process. So no matter what we're doing here, the denominator never stays the same. We love the denominator. We don't want it to change, right? You love your puppy, you want to keep your puppy happy, right? You don't want it to turn into a crazy, maniacal, car-chasing hound, right? You want it to be that fluffy little dog if that's what you like. So the denominator I'm always going to keep. Now, the other thing is that in a mixed number, let's say 2 1/4, the neat thing is that that tells us how many divisions we're going to break up our wholes. So even though I have 1 whole pizza, I still break it up into 1 or into 4 pieces. So what percentage or what fraction does the whole represent? Well, 1, 2, 3. How many pieces? I got 4 out of 4. Here I have 4 out of 4. Now, this is why you have to remember that this fraction line also represents a division, where each dot represents the number. So I have a number divided by a number. 4 divided by 4, what is that? That's 1. Interesting. That gives us 1 whole. This would be the second whole, because 4 divided by 4 gives me 1. So this is where this big 2 comes from. 2 wholes and 1 quarter. Let's say you need 2.5 cups of flour. Well, you take a whole cup. Now, you could take 4 quarters of a cup. It's not going to be quite as accurate with flour, but you could take 4 quarters, then 4 quarters, then 1 more quarter. So if we look at it that way, how many quarter cups? How many quarter cups? Let's say we don't have a full cup, we don't have a half cup. The only thing we have is a quarter cup measure. How many quarter cup measures do we need to use to get 2.25 cups? Let's count them. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. I would need 9 quarters. Oh, bingo. Look at that. There it is. Improper fraction. This is my mixed fraction. This is my improper. This is just like a quiz. There's my improper fraction, 9.25. But you see here how that is just 2? Now, a little bit of magic. How many wholes can I take out of 9? So remember, a whole is 4 out of 4. So let's just see. What happens if I take 9 and I minus 1 whole? What am I left over with? I'm left with 5. Okay? Now, if I do that again, I start with 5 quarters and I minus 4 quarters. What am I left with? I'm left with 1 quarter. But we have to take out quarters when we're converting from improper back to mixed. Okay? So that's the basic thing. So when we're doing this, we're saying how many wholes do I have and how many quarters do I have left over? And here, how many 4s can I take out of 9? Well, 4 times 2 is 8. And how many do I have left over? I have 1 left over. So let's try and do this just with some math now, because that's kind of the visual. Let's get into some other stuff. I'm going to put 3 fractions down. Let's go 4 and 1/5. Let's do 10 over 7 and 22 over 5. Sometimes I can't. There we go. Good. All right, now, first thing we're going to do is we're going to identify what kind of fractions these are. Remembering that if I have a whole number and then a fraction, that's going to be a mixed number. And if I have a is larger, the numerator is larger than the denominator, that's an improper fraction. First one. Come on, focus. There we go. Like magic. 4 and 1/5. This is 1, 2, 3, 4, 5. 5s are hard. So this is going to be 5/5 plus 5/5 plus 5/5 plus 5/5 plus how many? 1/5. Now, even though we haven't done this, when you add fractions, as long as the bottom is the same, you just add the top. So I get 5, 10, 15, 20, 21. What do I do with the denominator? I keep it the same, 21 over 5. So you can always sketch these out to give yourself an idea. However, let's take a look at this in a different way. What we're actually doing is that we are dividing this, or we are multiplying this whole number by how many pieces we have. 1 whole equals 5/5. So the key here is that we are going to multiply the 4 times the 5, the whole number times the denominator, which gives me 20. And then we are going to add the remainder. Plus 1 equals 21. What do we do with the denominator? We keep it the same, 21/5. All right, now let's do the process in reverse. I've got sevenths. Well, if I had 2 wholes, it would be 14, correct? So if I have 7 sevenths here, how many would be left over? So that's 7 sevenths, but I have 10 sevenths in total. So 7 plus what equals 10? 3. So in my second pie, I would only have 3 pieces left. So this 7 is 1 whole. So I have 7 plus 3. 7 is 1 whole, that's 1. And how many were left over? 3 sevenths. Other way to look at it. If I have 10 over 7, I go like this. Similar to when we were doing the factors and such. How many times does 7 go into 10 without going over? What's the closest I can get to 10? Be 7 times 1. So that's 7 times 1. That tells me that I can take 1 whole pie out of this set of fractions. Now, 7 times 1 is 7. So 7 plus blank equals 10. So how many do I have left over to get to 10? Well, that would be 3. So I get 1 3 sevenths. Try this one. I get 22 fifths. So how many times does 5 go into 20? 2 without going over. Well, 5 times 4 gives me 20. So I can take 4 wholes out, and I have 22 at the top and 20 here. What's the difference between them? 2 fifths. That's how we convert back and forth between. Now, if you're struggling, don't worry. We're going to practice this a lot. It's not a really easy skill, but you'll get it. Okay, so this is one of the keys for when we get up to higher level fractions. Good luck, guys.